I'm given that I have a right triangle and I'm given one trig function of the angle theta, and I'm looking for exact values of the other 5 trig functions. There's a couple different ways we can dive into this. One of them is, let's draw a right triangle. If you like pictures, if you relate to pictures, that's a good way to go. I usually draw a picture. So there's my right triangle, that's my right angle. Theta is one of the acute angles, doesn't really matter which one you pick, I'm going to pick this one. Sine theta, the sine is the opposite side over the hypotenuse. So 5 is my opposite side from that angle, 7 is the hypotenuse, and there we go. So if you're thinking sine theta, 5 over 7 is opposite over hypotenuse, we get a nice picture, and we see that we're going to need to find the third side, which we can do with the Pythagorean theorem, no problem. The other way to think about it is sine theta is y over r. If you like that way, that's fine too. The next thing we're going to need to do is find x, and we're going to do that using the Pythagorean theorem. So either way you start off, we're going to need the Pythagorean theorem. So we're finding x. If you have a picture, it'll be that missing leg. Pythagorean theorem, x squared plus, let's see, y was 5, the opposite side, 5, that's not a 5, equals the hypotenuse squared. So now, let's finish this out here. We'll square some stuff, we'll subtract some stuff. X squared is 24, I need x. The question is asking for exact values. If I put this in a calculator, it'll give me a decimal approximation, which is not exact. So I'm not going to put it in the calculator. Instead, I'm just going to simplify the square root here. The square root of 24, 24 is 4 times 6. The square root of 4 is 2. The square root of 6, I don't know what that is, so we'll leave it underneath there. And now I have the value of x, the value of my missing leg of my right triangle. Now that we have all 3 sides of the right triangle, now that we have x, y, and r, we're ready to answer the question. The sine, we already had. The cosecant is its reciprocal. Flip it over. The cosine is, you can think of it as adjacent over hypotenuse or x over r, whichever one works for you. So here's adjacent over hypotenuse, x over r. The secant is its reciprocal. If you want to rationalize this, you can, and you'll get, what do you get? 7 root 6 over 12, and that's fine. It's also fine if you leave it just like this. I will live with the radical in the denominator. I'm going to assume that by this stage in the game that you could rationalize that if you wanted to, so I'm not going to make you actually do it. Then we need the tangent, which is opposite over adjacent, or y over x. And the cotangent is its reciprocal. And we're there.